So with our first learning goal being using distributive property to simplify, we're going to practice one problem is all. Okay, so make sure that you are tuned in here so that you're going to be able to do this on your own. So when you cannot combine terms inside parentheses, now in the ones we were doing in your workbook, could you have added together the numbers inside the parentheses? Aren't they like terms? Anybody remember what any of those numbers were? If there was a 1 plus 4 inside parentheses, could they be added together? Yeah, they really could, because you could add 1 and 4 together and get 5. But what if you can't? Like, could you put y plus z together? No, they're not like terms. Y's are not like z's. They're not like terms. So when we don't have like terms, and there is a multiplier in front of the parentheses, we're going to do distributive property. It's kind of a big word, so make sure you spell it nicely. Distributive property helps us to simplify. Distributive. That silent E at the end. So here's an example of just an expression. This is not an equation to solve, but rather an expression. 3 in front of x minus 4 in the parentheses. My first question off to the side here is, are x and 4, what are in together in that parentheses, are they like terms? Are x and 4 combinable? No. Big fat no. Well, in the next line that went down, what did I do there? Harley? No. Can you just put N for no? Why can't you just write an O behind it and just write no? That makes more sense. Okay. So my next question was, on the next line, what did I do? When I wrote 3 in front of parentheses, x plus negative 4, what did I do? That you're always supposed to do. Change. Hey, good morning! We did have this day after school, but now we don't. We're here. Add the opposite. Add the opposite. So it's x plus a negative 4. Okay. Oh, we made it past that. What is the multiplier in this? Harley? 3. The number out front, that really means 3 times the sum of x and negative 4. So our multiplier is 3. So what we're going to do to show our work for this is to get rid of the parentheses. We're going to show that we're going to take that multiplier 3 times each, let's put a box around that, times each of those terms inside the parentheses. We bring down the plus sign that's in the parentheses, and we also take the 3 times the negative 4. Put a box around that also. We have 2 multiplications to do to help simplify this. What is 3 times x, class? 3x, okay. And what is 3 times negative 4? Negative 12. Can that be cleaned up now that we're done? Or would that also be the same as, also known as? Well, Harley came to school today, good deal. Harley.
3x minus 12.
3x minus 12, okay. It's just always good that we can clean them up too. So when we use distributive property, it's a way to simplify. It's a way to help us get the equation, to get the expression simplified so that in the equation we can solve with it better. Okay, I'm going to have to just stop here and do some calibrating. Maybe. Okay, so we're going to practice one solving equation problem is all. So as I said, be tuned in, okay? Okay. So when solving equations with an expression like this, like we just simplified, we will simplify before we solve by doing distributive property. So it's kind of another way of getting the equation ready to solve. Okay, what do you suppose I'm going to suggest we do first? Class, come on.
Add the opposite.
Change subtraction to add the opposite. So is this a subtraction sign at the beginning? It's a what?
Negative.
That's just a negative sign, saying we got a multiplier of -2. Let's slip a 1 in between that negative sign and that x, because that's really a -1x, correct? It's an invisible 1 not there. Change that subtraction to add, and what's the opposite of 4? -4. And so all we're doing is changing subtraction to add the opposite, and the other thing we did is we slipped a 1 in there so that we can see that we have a coefficient of -1 on that x. Now it is ready for us to simplify. By the way, can -1x and -4 be put together inside those parentheses? No, they're not by terms, are they? So we're going to have to do our distributive property, which says take the multiplier times each term. So there's our first multiplication. And then our other multiplication also has to use that multiplier of -2. So there's our second multiplication. And then we bring down our equal 6. So we're getting the equation ready. We're simplifying. We're not solving yet. Okay, class, what is a -2 times a -1? That's a +2. So this is going to become a +2x. The x is still there. And what's a -2 times a -4?
+8.
+8, so +8. And we still have our equal 6. Is it ready yet? Can 2x and 8 be added together? No, I think it's ready to solve, isn't it? Okay, so we're ready to solve this. We're going to do the same thing to both sides. Okay, what's the first step we're going to make? Carly?
Add -8 to both sides.
Add -8, because we want that +8 to zero out. So we're going to add a -8 because 2x says, get out of here, 8. So they're gone. And we have 2x left over here. And what happens on the other side? 6 plus -8. What is that?
-2.
-2. Okay, Danny, what are we going to do next? Divide by 2. Okay. Danny says divide by 2. Everybody want to agree? Because x is being multiplied by 2, the coefficient is 2, so we divide by that coefficient. So now we have an x, and what is x equal to? Negative what? 1. -1. Okay, we're going to do a check problem. I think we're going to have more white space over here, so let's go over here and do a check. Anybody remember what is really important in a check problem? Where do you check it? Where do you check it? Like you just pick somewhere along the way, like 2x equals -2 and plug it in? No, you have to start where? At the beginning, yeah, when it was -2x or -2 times -x minus 4 equals 6. Well, guess what we're going to do before we substitute? We're going to give it add the opposite name and put that 1 in there again before we substitute in. So we haven't even started checking yet. We're just getting ready again. So -2 Negative 1x means take negative 1 and multiply it times the x value, which is also a negative 1. Let's just put a little box around that showing where we did our substitution. And then we just bring along everything else that doesn't have anything to do with. All else we're going to do is, they don't have any x's involved in them. Okay, order of operations says, take care of parentheses first. Order of operations also says, inside of parentheses, you got to follow order of operations. So what would we do first? Would we multiply first or add? Multiply first. So we're going to take negative 2 and put it in front of parentheses still. What's negative 1 times negative 1, class? 1. Okay, what does order of operations say to do next? We're not solving, we're not simplifying, we are checking. We just follow down using order of operations after we substitute. Should we distribute this negative 2 or should we add these guys together? Add these guys together in the middle here, in those parentheses. What is 1 plus negative 4? Negative 3. Remember, this means multiply. Negative 2 times negative 3, what is that? A positive 6, because when you multiply two numbers with the same sign, it turns out positive. And then we have our equal 6. It checks, doesn't it? We have a good solution. Okay, make sure you have good work showing, because again, this is the only one we're going to practice. We're going to go to a whole different thing again now. So questions on this? Anything unclear? Okay, then let's go to the backside and let's work with our other learning goal today, which says I can solve complex distance rate time problems, or in other words, I can solve complex word problems. Okay? So our directions say solve the rate problems, use algebra to solve each problem, use arrow diagrams to represent the problems if needed. So I'll show you some arrow diagrams and you can decide if you need to use them or not when you're doing this. Not all of the problems involve opposite directions. So they're just kind of giving us a little hint there that not all of your arrow drawings will look alike, okay? Okay, go ahead and read that number 1 to yourself first of all. And feel free if, it helps you right now to just cross out some of the stuff that you're like, I don't really think this is important, I can get this out of my sight. And then I'm going to suggest that the only other thing we do at the moment is this, how long, okay? Okay, anybody think they know how we can do a basic, simple arrow drawing to show what's going on here? Tell me what's going on in this story here. What's happening? Sam?
2 mice are racing.
Two mice are racing?
Yeah.
Okay. What are they racing to? Food. Okay. And what's happening? Are they starting at the same place?
Yes.
Okay, they're starting at the same place. So let's just go up here and we're gonna need all this other white space here though too. So they're starting at the same place and you said they're racing in opposite directions. Okay, so one's going that way and the other one's going that way. They're trying to get to the food. Okay, do these rats or mice? Oh, they're rats. Oh, they're not mice, they're rats. Okay, do these rats have names?
Chunky and Whiskers.
Okay, let's make this side Chunky. And the other one's name is what?
Whiskers.
Whiskers. Oh, nice name. Okay. So Chunky and Whiskers are starting at the same place. They're heading in opposite directions, seeing who can get to the food. And, okay, so that's kind of like our basic arrow drawing. Anybody want to tell me anything that they crossed out? What's something that you crossed out in this? Caden, did you cross anything out yet? Okay, what? Okay, and we use that to help us basically get our drawing, right? Okay. Harley, something else that you crossed out? The whole second sentence, the doors on each side open at once, okay. And the rats run toward the food in the maze, which is what we said they were going in. So it says, and Chunky now is running in one direction, Whiskers is running in the opposite direction. Is that kind of important information? Yeah. So we probably should underline that Chunky is running at the rate of 4 inches per second. Whiskers is running at the rate of 6 inches per second. How long will it take for them to be, 50 inches apart? So that means when they get, we want to know when will this whole distance here be 50 inches? When will that whole distance be 50 inches? When will they be 50 inches from each other? Okay, anybody remember how we started these rate problems last week? It's the first thing we did. Harley? Okay, we set up some sort of a fraction. Okay, what could the fraction be that we set up in this one? What's the rate? What's it measured in? Inches per second. Okay, so we're going to go inches per second. That's the rate. What do we want to happen? We're going to multiply that by something. What are we going to multiply this by? Seconds, because we want the denominator to cancel away. So we're going to take it times seconds. Because then these guys will cancel. And we'll end up with inches, right? Okay. Well, then the other thing we decided we had to do next was, this helps us set up our multiplication in our equation. That's the reason we do that. Next thing we have to do is decide what is x going to represent. So let's go look at our circled part. It says how long. So what should x represent, Mikia?
Seconds.
Yeah, the number of seconds. Okay. So next thing we do is, it's kind of like our way of making sure we set up a good equation. We got Chunky. We got Whiskers. And do we have a total? Do we have a total? Yeah, we do. Okay, so let's write total. How long will it take? Well, they're both running at the same time, right? So we're going to have to do an addition problem. Well, one does plus what the other one does should equal a total. So remember, there was a reason for us setting up this. It says, take the rate times the number of seconds, and that will tell you how far they go. So what would we do for Chunky? Sam? 4 times x. Chunky's running at a rate of 4 inches per second, and he's going to run for x seconds. We just don't know how long that is yet. What are we going to write for Whiskers? Class?
6 times.
6 times x. Oh, it seems like Whiskers might be a little bit faster, huh? And altogether, their distance should equal what? 50. Now, remember, we know that this gives us 4 times x gives us inches because the seconds are going to cancel away. So we are taking inches and adding to inches, and in the end getting inches. Makes sense, right? Add inches to inches and get inches. Okay, so now we're gonna get rid of the multiplication dots and set up our equation. Is it ready to solve? No, what can we do? What can we do? Wait. Pardon? Okay. Not yet. Not yet. We're still getting ready. You're close. What are we going to do to get it ready before we divide? No. I know. At this point, it's just throw something out, right? I get it. Hannah? What are we going to do? Yeah, we add those x's together. They're like terms. They can be put together before we solve this. And now that they've been put together, we have 10x, right? Is it ready to solve now? Now it's ready. What are we going to do to both sides, class? Divide by that coefficient of 10. And what does our x equal? 50 divided by 10 is 5. Okay, and that's 5 what? Seconds. We were looking for the number of seconds. Okay, so now let's go over here in some white space and write our sentence. It will take 5 seconds to be 50 inches apart. Now notice, we don't know if they found the food yet. All we were answering is how long is it going to take to be 50 inches apart? Okay, so remember from last week, all of this extra stuff we do over here on the side, on the right side there, that helps us make sure that we set up good equations, because they're not always going to look like this. Okay, let's go on to our other one. We have one more we're going to do. 3 workers in a strawberry field are picking strawberries. You think that's important? No, it is, kind of somewhat decent information. Well, we know there's 3 workers, though. That kind of sounds like that's going to be important. They all start at the same end of the field and move down the field as they pick strawberries. Well, that's kind of important in our drawing, right? So we now know we have 3 people who are starting at the same end and move down the field as they pick strawberries. But in reality, it's not going to matter in setting up our equation. So let's just start our picture, though. We have 3 people moving down the field, going in the same direction, starting at the same place. So one of those people is Michael, another one is Anna, and another one is Tyler. And the question is, how far will they have moved all together? What operation do you think we're going to do here? How far will they have moved all together? So, yeah, add. We're going to add. Oh, we got to be really careful here. The rates are given in feet per minute. Feet per minute. How far? Okay, so it looks like we better start doing some underlining here. Michael is moving 3 feet a minute. Anna is moving 5 feet a minute. And Tyler is moving 4 feet a minute. How far will they have moved together after 1 hour? What are we going to have to do before we decide, set this equal to a total. What's that total gonna be, a 1? I get?
60 minutes.
Yeah, we have to be talking in the same terms here, so we have to take that 1 hour and we have to say that equals 60 minutes. That's important. So it's kind of like we're crossing out that 1 hour and making it 60 minutes because the rate was given in minutes, feet per minute. Okay, so let's give them just their initials. M for Michael, plus A for Anna, plus T for Tyler, because they all start with different letters, so that's good. Equals total. Okay, well, we can't start setting up our equation yet, though, can we? What do we need to do? Write down our rate, feet per minute. What's that going to get multiplied by? Feet or minutes? Minutes, the thing on the bottom. So that our multiplication should represent the number of feet that they've moved. So now we need to say, what is x going to be then? How far? So what's x going to represent? Number of feet. So our multiplications are going to give us feet. And our x is feet. So when we add, if our multiplications give us feet, we're going to be adding feet to feet to feet, because we're going to set up multiplications. Feet plus feet plus feet better equal feet. Okay, so what are we going to do for Michael? His rate times the time. He's moving 3 feet a minute, so times the time. Times 60. After 60 minutes. We already know how long. We are doing how far. Wait.
60 with 3 hours.
No, what's happening here is we're taking 3 feet over 1 minute times 60 minutes. So the minutes cancel away and we end up with 3 feet. Okay, so this is really feet. Or we end up with feet, I mean, not 3 feet. We're still taking 3 times the 60. Okay, how about Anna? What are we going to multiply? 5 times 60. And again, these are feet. Plus Tyler is moving at a rate of 4 feet per minute, so 4 times 60, and again that tells us how many feet Tyler moved. And altogether, they moved how many feet? Altogether, they moved how many feet? X, that's where our X is. We're solving for how far they have moved all together. So X feet. Okay. So 3 times 60 class is 180 because 3 times 6 is 18, attach that 0. 300. 240. Now we'll follow order of operations, right? 180 plus 300, how much is that?
480.
480. We'll set up your addition problems off to the side somewhere if you have to. 480 plus 240. That one I might not want to do in my head just in case I'm not I'm gonna remember that there's gonna be some carrying going on here. What does this add up to? Idea? 720. 720 what again? Feet. We were adding feet together. So our sentence, they will move, we'll say move, 720, don't abbreviate in sentences. They will move 720 feet all together. Okay. Whew. We made it. Questions on these? So this is not new stuff back, it's just more practice of these word problems because we're gonna get so good at them. So anybody need this up here longer? Longer the note? Got it? Okay, we're gonna stop them and